In today's pro tip, I'm going to reveal to you the shocking truth about volts. If you're doing anything with networking or power over Ethernet, you need to know a few key basics. And in pro tips on PoE basics, I'm going to show you what you really need to know in a way that a non-technical person can understand. You can find the full series in the link in the description below. Warning, this will not be an exhaustive tutorial on electricity, because if you wanted that, you'd be watching SparkFun's full series on the topic. I'll add that to the link below as well. Let's get started. I'm Tyler Andrews, head Shifu here at PoE Texas, where we nerd out on power over Ethernet all the time. If you enjoy this video, don't forget to like and subscribe. If you hit that bell icon, I personally guarantee I'll ping you with the best content around on low voltage and Ethernet projects. What are volts? Actually, the real question is, why should you care about volts? You just need to install a camera, Wi-Fi access point, or something on a network. Volts are an engineer or electrician thing, right? No, you need to know so you do it correctly and you know when you've got a problem. Simply put, volts are a way to measure energy. Let's break down volts in detail. Like I said, volts measure the potential energy of a bunch of electrons. The more potential energy they have, the more work each electron can do. An Italian guy named Alessandro Volta first came up with the idea that electrons have potential energy. So we used his name to give that energy a unit, the volt. It's usually written as a capital V. Sometimes it will have an AC or DC after the V. And we'll cover that in another tip. You need to know that most networking devices start at around 2 volts. That's what the TCP/IP signal runs on. Then it goes all the way up to 56 volts where power over Ethernet operates. You need to know that because you need to match the volts of your device with the volts of your power supply. They have to match. The current and the power draw of the device, which we'll cover in a future tip, just need to be less than the power source, but the volts must match. Now let's see what this looks like live and firsthand. By an amazing feat of engineering, we have been able to use a camera down at the microscopic level to see what it looks like when electrons run through a line. It surprisingly looks a lot like kids. Welcome to the Electron Cam, everybody. This is where we can see electrons at the molecular level. And you can see here, we have an electron captured on the screen, ready to move. We pause the video so we can see some details here. I'm going to mark him with electron E. That's the typical symbol for an electron. Now, what I'll point out is while we're here, the hand is moving and the hair is bouncing and the feet are moving. Those are all indications of the energy state. Now, I'm going to talk to you about current flow briefly so you can tell the difference between current and volts. So I'm going to go ahead and release this electron here and get him moving again. So you can see those legs moving and pumping, and he's got lots of energy. And then we've got our instant replay action going on here. So I'm going to point out here, he's moving through this hallway. He's moving through this plane like this. That is what we call current. That's when electrons move through a certain point in space. That's a measure of current. Now we're going to talk about why that's important in a second. But the key here to note, his feet are still moving. He's got lots of energy that's pushing him through the plane. That's what we call volts. His energy state is different than his movement. And let's talk about why. This is really important. So we've released him now, and he's moving down the hall. Pretty soon, he's going to approach an obstacle, and he's going to slow down, folks. And here we go. Now we're going to get that face just right. If you look at his face, this is really important. He has arrived at an obstacle. It could be a capacitor, it could be a transistor, it could be anything, whatever it may be. He stopped at an obstacle and he is not moving. So his current has stopped. He's not moving. But here's the important thing to note. Check out that face on that electron. This face says, I still have a ton of energy. I'm ready to go. I'm ready to move. Somebody opens that door and lets the electron go through, he will start flowing again. And these electrons are just crazy enough. If you got close enough to that balcony on the outside, he will literally go over the balcony rail in the air at you because he's got enough energy. That is the secret about volts and what you need to know about them. Volts, even if they're not moving, the potential energy of the electron is still there. The electrons are ready to move, they're ready to jump. So if you get close enough, that electron will jump right through the fence, through the capacitor, whatever, go through the air and land on you. That is why we measure volts whenever we're touching or working with electronics, to make sure the volts are safe to touch. You don't want this kid running all over you, because look at that face. He's got a little bag. It's going to hurt. Oh, it's going to be a lot of pain. Let's take you back out of the electron level and we'll wrap this video up. So if you've enjoyed this video and what I've been able to show you today, like and subscribe down below. Hit the bell icon. Follow us on Facebook or Twitter, or check me out on LinkedIn. Now, first and third Thursday of every month, we do a live stream for all of our guests. So if you want to ask questions, get to know more, meet some guest hosts and stars in the world of ICT and networking, come join us the first and third Thursday of every month. Thank you very much, and we'll see you at the next video.